Okay, guys, so I'm going back. So this is your second recording from section 3.3, and we're going to start right now. So before I finish my first recording on talking about local maximum and local minimum, here we're going to talk about absolute maximum and absolute minimum. So absolute maximum is the highest point on the graph. Okay, so it's the highest point on the graph. So in this case, this point, u and f of u, it's the absolute maximum. Absolute minimum, it's the lowest point on the graph. And if we talking about the value of absolute minimum, the y coordinates the one which we needed. Okay, and x coordinate just give us exactly like direction. This is where that absolute minimum is. So absolute minimum, the lowest point on the graph, absolute maximum, the highest point on the graph. Okay, so here you guys have a definition, but again, let me just update that. Hold on. Oh, what just happened? Okay. Flip it. Okay. Okay, it just takes time to save it. Okay, right here. So absolute maximum is the highest point on the graph. Okay. Absolute minimum is the lowest point on the graph. And sometimes the local maximum can become, it's also absolute maximum. And the local minimum can become absolute minimum. Don't forget that local, you may have more than one. Usually the absolute maximum and absolute minimum is just one y value. Okay, so we're going to start talking about the example right here. This is on slide 27. We have to find the absolute maximum and absolute minimum from the graph of the function. So you have, and also they asking to find the local maximum and local minimum. Okay. So what I'm going to do, I'm going to copy and paste that. I'm talking about this one. Whiteboard so we can see it. Okay, so let's talk about problems. Okay, so first answer A. Okay, let's talk about graph A. So absolute maximum is the point right here. This is the highest point on the graph, so is 3,6. Okay, and if they will ask you for the y value, what is the absolute maximum, and you only have to answer the question using one coordinate, you would just say y equals 6 because the height of the graph. Now absolute minimum is at the point, so the lowest point on the graph right here is 0, comma 1. Now let's talk about local maximum. So local maximum, to review that, that's the point where the graph switch from increasing to decreasing. So point 3 comma 6, it's also local maximum because here the graph switch from increasing to decreasing. So so point 3 comma 6, it's also local maximum, and local minimum is at the point. Local minimums, that's the points where graph switch from decreasing to increasing. So here the graph change from decreasing to increasing. So local minimum will be 0.4 comma 4. So like you see, local minimum is not the same with absolute minimum. Absolute minimum is the lowest point. Now let's talk about part B. They ask to find absolute maximum, graph B. So absolute maximum is at point. So absolute maximum, that's the highest point on the graph. So absolute maximum is y equal 3. So it's at the point 5 comma 3. Absolute minimum, so absolute minimum, now look what happened here. Very important. Let's just review that the open circle means that we don't have that point on the graph. So to find the absolute minimum, graph B, it's not continuous because this is what happened with graph B. We have function which decrease, we have a gap, we stop, and then functions start increasing. Okay, so at point 3 comma 1, it's not part of the graph. So what is the absolute minimum? What is the lowest point here on the graph? Technically it should be point 3 comma 1, but it's not part of the graph because of that open circle. So you cannot really tell what is the lowest point on the graph because look what happened here. Function, you cannot really tell me what is the height right here. Okay, we cannot really say if this is 1, or again it cannot be 1 because point 3 comma 1 is not part of the graph, but maybe 0.999. And the same thing, this is not lowest point on the graph. We cannot really read it. So when you cannot tell what is the lowest point of the graph, we don't have absolute minimum. So here we have, the answer will be no absolute minimum. You cannot tell what is the lowest point on the graph because that lowest point was removed from the graph because of that open circle. Now let's talk about if we have local maximum. So just to review, local maximum, it's a point where graphs switch from increasing to decreasing. So we don't have local maximum here because 5 comma 3, it's absolute maximum, but it's not local because look, that graph stop here. So to find the local maximum, that's the point at which graphs switch the behavior. So we, from increasing to decreasing. So we don't have local maximum. Now let's talk about local minimum. Okay. Local minimum, it's a point at the graph where functions switch from decreasing to increasing. So technically, that point should be here, but since 3 comma 1, it's not part of the graph. We have open circle. So this point we cannot call as our local minimum, okay, because it doesn't exist. It's not part of our graph. So we don't have local minimum. So no local minimum. Let's talk about graph C. Okay, so graph C. What happened with graph C? We have to find absolute maximum. So the highest point on the graph, it's right here at 0.5 comma 4. So that's our absolute maximum. Let's see if we can find absolute minimum. So absolute minimum, the lowest point on the graph. So what happened here? And don't forget that when we talk about absolute minimum, maximum, or local, so technically the coordinate which matters is y, because y is responsible for height. So here when I'm looking for lowest points on the graph, okay, for absolute minimum, so every single point here in that segment from 1 to 2, okay, has y coordinate equal 1, which is the lowest y value. So how are we going to describe that absolute minimum? So the absolute, let's put it that way, the absolute minimum value is 1. So don't forget that this is y coordinate, y value. So when we describe maximum and minimums, we're using y values. X coordinates just give you the direction where you can find that absolute minimum. So absolute minimum is 1, and is located at the interval 1 comma 2. Okay, so what I just did for you guys, so again, absolute minimum, it's 1. That's the lowest y value of this function, which is 1 right here. And x coordinates just give you the direction where you can find that absolute minimum. So that's why I said that absolute minimum it's 1, and you can locate that absolute minimum on the interval from 1 to 2 right here. Okay, so now let's talk about local part C. Let's check if we have local maximum. So local maximum, it should be the point on the graph where functions switch from increasing to decreasing. So let's see if this graph has local maximum. If we have the point where functions switch from increasing to decreasing. So we don't have that here, okay? Or from constant to decreasing. So we don't have local maximum. Now let's talk about local minimum. So local minimum, it's the point on the graph where functions switch from increasing, from decreasing to increasing, or from constant to increasing. So local minimum will be also 1, because look what happened here, this part of the graph and this part of the graph right here. Okay, what happened? We have a switch. Okay, the function switch right here from constant to increasing. Okay, so local minimum is at 1. So local minimum is 1, y value equal 1. And now we're going to describe that using the x coordinates. So where that local minimum happen. So technically, again in orange, every single point from the interval from 1 to 2 using the x coordinates has the same y value, which is 1, because 1 represents the local minimum. So that local minimum is at the interval from 1 to 2. For all x values from interval 1, 2. Okay. So again, local minimum, it's 1. Also absolute minimum, it's 1. And it works for all the x's from the interval from 1 to 2. Okay. Now let's talk about D. Let's describe D. Okay. Graph D. Let's talk about absolute maximum. Okay, so look what happened to graph D. This function keeps going up to positive infinity. So you cannot really tell me what is the highest point on this graph, because this function keeps going up to positive infinity. So none. We don't have absolute maximum. You cannot really tell. To have absolute maximum, you cannot say it's infinity. You have to give very specific y, the height of the graph. Now, absolute minimum value, so the absolute minimum value, so the lowest y value, it's at 0, is 0, and is at x equals 0. Okay, so x gives you the direction when you can find the lowest minimum, the absolute minimum. So when x is equals 0, y coordinates also equals 0. So here, absolute minimum is at point 0, comma 0. However, when we talk about minimum, the most important, it's the y coordinate. Okay, x just give you the direction where you have to look for it. Now let's talk about local max. Again, don't forget that to have a local max, graph should be switching from increasing to decreasing. Since graph D, entire graph is increasing. So we don't have that change of the behavior on the graph. That's why we don't have local maximum. Okay. Also, there is no local minimum, because to have local minimum, the graph should be switching from decreasing to increasing, or from constant to increasing. So we don't have that change because entire graph is increasing. So you don't have local minimum. So again, to have locals, the graph has to change the behavior. And the last one, graph E. We're going to describe graph E. So graph E, here, let's talk about absolute maximum. So what is the absolute maximum value if we have any? So that should be the highest point on the graph, the highest y coordinate. So look what happened with this graph. Again, just be aware that open circle on the graph means that this point doesn't exist. This point, it's not part of the graph. So our graph, it's not continuous. Because point 1 comma 4 was removed from the graph, so you cannot really tell me exactly what is the highest point, what is the highest y value. Again, we don't want to estimate. It should be point 1 comma 4. However, we remove that point from the graph, so we cannot really give the specific highest y value, which should represent absolute maximum, so we don't have it. We don't have it. Don't forget that 1 comma 4, it's not part of the graph. Now, let's talk about absolute minimum. So absolute minimum, okay, you should be able to give the lowest y value of this graph, the lowest point on this graph. So look what happened with this graph. That means that your function keeps going down to negative infinity. So again, we cannot really decide what will be the lowest y value. And when you have case like that, means we don't have absolute minimum also. Okay. And let's talk about local maximum. Local maximum is at the point where functions switch behavior from increasing to decreasing. And we have that right here. Here function is increasing, and then at point 4 comma 3 change to decreasing. So we have that change at point 4 comma 3. So point 4 comma 3 represents local maximum. Okay, so local maximum is at 4. So local maximum value is, I'm sorry, it's 3. And x equal 4 just give you the direction where you can find it. Now let's talk about local minimum. Local minimum, that's the point on the graph where functions switch from decreasing to increasing, which technically that's where we have that change. However, point 2 comma 2, it's not part of the graph, so we don't have local minimum. Okay, so please study those type of problems. They're very important that we understand. Okay, let me understand it. Next, let me go back to PowerPoint. So we solved this problem. Also, you guys have a detailed explanation of each graph right here. So you can study that. Okay, next one is extreme value theory. So extreme value theory tells you that if function is continuous function, which domain is close interval from A to B, then function has absolute maximum and absolute minimum. So all the time, if the function has the domain as a closed interval, your function will have absolute maximum and absolute minimum. So let me see if they provide the example here. So extreme value theory, I want to explain that based on this graph right here. So you can apply extreme value theory on this graph because here the domain of this graph is the interval for x is from 0 to 5, and the extreme value theory tells you that if the domain of the function is closed interval, then this function has absolute minimum and absolute maximum. So it works because look what happened. We have absolute minimum, which was y equal 1, and we have absolute maximum, which was at y equal 4. So that's the extreme value theory. Also, extreme value theory works on graph A. Okay, the domain of this graph, it's our axis starting from 0 up to 5. So the domain is closed interval. And if the domain of the function is closed interval, your function has absolute minimum and absolute minimum. And look what happened. We had absolute minimum at 1. Absolute minimum value is equal 1 for x equals 0. And absolute maximum is 6 at x equals 3. Okay, so that's the extreme value theory. So extreme value theory just states that if domain it's a closed interval, then we always have absolute minimum and absolute maximum. So here, use the graph utility to approximate local maximum and minimum. You guys can read that. I'm going to skip that because this is using the technology, which is TI-84 or graphing calculator TI-83. And they want you to graph those functions using calculator, and they teach you how you can estimate maximum and minimum using calculator. We're not using that in the class, so I'm skipping this part, okay? Because graphing calculator are not required for this class. So you guys can go ahead, those who have graphing calculator, read it, you can try it, you can apply it. But I'm going to skip this part. So I'm going to finish recording too when I talk about absolute minimum and absolute maximum. And the next recording, you're going to see about finding average rate of change. So right now I'm going to stop. And the last part of section 3.3 is about finding the average rate of change, which is technically finding the slope of the function. Okay, thank you.